Thank you for joining us today. My name is Ed Lima, and I am a Solutions Architect with AWS. We are here to talk about progressive web apps, GraphQL, and our new service, AWS AppSync. AWS is the best place to create, prototype, experiment, develop, deploy, implement, secure, and scale all sorts of applications, mobile, web, or desktop. Mobile applications set the bar for the user experience these days. Everyone has a mobile phone, and everyone is used to the experience mobile apps provide, such as real-time communication, offline access, and background synchronization. For example, I had to go overseas a couple of weeks ago. My sister just had her firstborn and my first nephew a couple of weeks before. I'm an uncle now. As you can imagine, my family already had about 500 pictures of the boy in a group chat we're part of. I was completely offline during the flight, but when I opened the messaging app, anytime during that trip, I was able to see my nephew's pictures. It brought a smile to my face. As soon as I arrived to my destination and got back online, everything was connected and synchronized automatically in the background. Another 500 pictures to catch up with. This is where the bar for applications is set with users now. Going to a browser and getting some sort of "you are offline" error message provides a really bad user experience. Everyone is used to access some assets cached offline and get everything synced in the background and they get back online. Everyone is used to instance and real-time access to their data. This is where the bar is set these days, and it will be a hard requirement very soon for web and all other sorts of applications. Let's understand how some paradigms, technologies, and AWS services can help to provide these capabilities to enhance and supercharge applications to also improve and enhance the user experience. Let's take a look at how a great user experience affects how people use their devices. This is a study from last year. Over 500% of digital media was consumed in a mobile device. These are very impressive numbers. Everyone has a mobile device these days. However, it is a crowded market. There's another study that mentions mobile users only interact with 5 apps daily, be it social media, videos, chat, games, or any other type of app. If your app is not in between those 5, you are not engaging with your users and you don't have a loyal audience for your application. On the flip side, mobile web apps last year had almost 2.5 times the amount of unique visitors when compared to mobile apps. Makes sense because web apps provide less friction. You just need to access a link. No need to go to the App Store, download an app, wait for it to be installed, try the app to find out if you actually like it. There's no gatekeeper App Store where I need to wait for a download to install the app before I can access it. Let's take a look at one of the main reasons for those impressive web app numbers. For quite a while, the term progressive has been around when it comes to web apps. What is it about? There's been a very popular movement for the past couple of years that relate to web applications. How can they help enhance the user experience? Let's find out. Progressive web apps, or PWAs, are responsive web applications that adapt and scale automatically to the screen size. They work well on a desktop, laptop, or mobile device screen. They are defined by a manifest.json file that is detected by the browser, and they are easily discoverable and can be installed on the home screen or application drawer, just like a native mobile app. So, in a nutshell, progressive web apps use new web capabilities to deliver a mobile app-like user experience. Progressive web apps are network agnostic. They work either offline or online. They are always up to date, no need to check the App Store for updates. They are secure. One of the main requirements is that they must be served over HTTPS. And they are easily shareable. You just need to share a link. This is an example of a progressive web app. The mobile browser detects a manifest.json file and asks to add the app to the home screen, which is basically installing it. Once you open the app, you are greeted with a splash screen and the browser interface is gone. The progressive web app is displayed in full screen, looks and behaves like a normal native mobile app. There are 3 main components to a PWA. The application shell. If you think about mobile native apps, one of the reasons they are so fast is because the user interface and all static assets are installed locally on the device. With a progressive web app, the concept is the same. The UI, HTML, CSS, and JavaScript are all cached locally in the device. The service worker is the main component, and it provides very nifty capabilities. It is basically a network proxy that detects the network state and directs requests to the cached application if offline or to the web application if online. It has other important features such as detecting if the cache is outdated and allows for automatic updates, as well as providing support for web push notifications that are essential to keep your users engaged. Finally, there's the local storage itself, where all the offline data is kept using things like IndexedDB. There's a thriving and growing developer ecosystem when it comes to PWA support. Lots of web frameworks such as React or Angular have built-in compatibility with PWAs and service workers. Developers can use different build systems and libraries such as Local4age. On AWS, the deployment is made simple and easy with our AWS Mobile CLI and Mobile Hub. With 2 mobile CLI commands, you can create an S3 bucket and CloudFront content delivery network support, then build and publish your progressive web app to the cloud in a matter of minutes. PWAs do a great job to raise the user experience bar in the front end. They help address some of the data and user experience challenges we mentioned, but not all of them. What about the back end? How can we make it more real-time and offline capable and friendly? Before we start, let's discuss how traditional data fetching works. Let's imagine we have a blog application backed by a REST API. If my client needs to access a list of blog posts, I have to make an API call to a specific endpoint posts. The API will return IDs for the posts. If I need data about a specific post, I have to use the ID I just retrieved and call another endpoint to get information about the post using the post-info endpoint. Maybe I need to now make a third call to get data about post by author, and so on and so forth. As my data requirements get more specific, I need to create different endpoints and customize them accordingly. You can imagine it won't scale well as the API gets more complex with more endpoints. It becomes hard to manage. There are some advantages to it though. REST is a true and tested API technology with established architecture patterns, and it's based on standard HTTP calls. However, if you need to build relationships between those endpoints, or if you need to query the data dynamically, or implement ordering and pagination, or get real-time notifications when data changes, you need to develop it yourself in the backend. REST won't support any of these features out of the box. Is there a better way? Well, as a matter of fact, there is, and it's called GraphQL. GraphQL was created in 2012 by Facebook and open sourced in 2015. Now it is an open standard. Basically, if you'd used Facebook since 2012, you've been making GraphQL calls for years. The idea behind development of GraphQL was to simplify data needs for both client product developers and server-side engineers, regardless of what languages you're using in either environment, rethinking data fetching from the perspective of product designers and developers. Companies such as Twitter, GitHub, Pinterest, and many others with a large amount of users are also using GraphQL in production. GraphQL, as the name describes it, is a data query language for APIs. It is also a runtime to fulfill those queries. It's very important to notice GraphQL is not a graph database. If you want to learn more about graph databases, I suggest you take a look at our new service, Amazon Neptune. GraphQL is expressed as a declarative language for requesting data from your application's backends. It uses a type system that allows to understand data requirements and get meaningful error messages, making it easier to use in prototype. GraphQL is able to get data from many data sources in a single request, allowing clients to receive the data they ask for. Nothing more, nothing less. It also has an interesting feature called introspection that allows to query the GraphQL schema to understand the data format and also helps document your API. I believe a picture is better than words to describe one of the main advantages of GraphQL. Let's go back to our example, a blog post application. In order to fetch the data to populate my front-end user interface, I need to make a call and get the list of posts and post IDs. Then I use one or more IDs to retrieve comments, so I need to make a second call. Then if I need to get information about the authors, I need to make another API call to a third endpoint. In order to get the data that I needed, I had to make 3 API calls because I was either overfetching or underfetching data. With GraphQL, I only have one endpoint and I only need to make one single API call. The data is retrieved from multiple data sources automatically for me, and these data sources can be anything. SQL, NoSQL, HTTP, it doesn't matter. GraphQL supports 3 types of operations: queries to read data, mutations to write or update data, and subscriptions that are specifically linked to mutations and allow to receive data in real time whenever data is changed or updated. Let's take a look at a more detailed example. Let's imagine we have a simple event tracking app. The first step is to create a GraphQL schema. We define our schema with an event type that has specific properties such as ID, name, when and where the event is going to take place. We also define a query operation to retrieve data about events from the backend. The client now invokes the query operation to retrieve the data. However, it only needs the ID and the name of the event. Notice it doesn't require any other data about the event. As soon as the operation takes place, the client gets the data as requested. But what if now the client needs to know when the event is going to take place? Well, it just needs to update the query and call the GraphQL API again. GraphQL allows to get exactly the data required whenever it is required. No overfetching and no underfetching. There's only one endpoint and there is no need to change anything at the backend or create separate endpoints. The client defines the data and the backend is optimized to provide only what the client needs. Until last year, I used to hear a lot from customers. GraphQL sounds great and I want to run my own GraphQL server on AWS. Well, let's stop right there. First of all, servers, they are so 2014. And when you talk about servers, you have to think about installing, patching, configuring, deploying, and if you're serious about it, then worry about high availability and auto-scaling. Lots of work and lots of undifferentiated heavy lifting. You should be focusing on your application and your business differentiators, and not the infrastructure to run your applications. The less time you spend on infrastructure maintenance and operations, the more time you can focus on new features and improving your application to speed up business outcomes. And that's why we released AppSync last re:Invent. The service just recently graduated from preview to GA, and it's also currently available in different regions in APAC, including Sydney, Singapore, Mumbai, and Tokyo. AppSync is a managed serverless GraphQL service, perfect for interacting with application data. It connects to resources in your own AWS account, allowing you to make your data available in real time or offline. It also supports AWS Lambda, our awesome serverless compute service as a source. You can use AppSync as a GraphQL facade for any AWS service through Lambda. It also allows to perform conflict detection and resolution in the cloud, instead of doing it in the client. AppSync integrates with AWS Identity Access and Management, Cognito User Pools, or you can use API keys, providing really powerful options to secure access to your API. There's also a new feature recently released. You can use external OpenID Connect providers to authenticate and authorize your GraphQL calls. But how does it work? Well, it's very easy to get started. You just need to upload your GraphQL schema, fully compliant with the open source spec. Alternatively, if you don't know much about GraphQL schemas, there's a cool feature where you can just point AppSync to an existing DynamoDB table, and it will automatically create a GraphQL schema based on the existing table attributes. With this schema in place, you can connect your data sources to AppSync using what we call resolvers. We currently support Amazon DynamoDB, our NoSQL managed database service, Amazon Elasticsearch, our managed Elasticsearch service, or AWS Lambda as data sources. And that's it. You're all set to start making GraphQL calls. AppSync will update data in real time and manage connections when the client's offline. In a good, usual AWS serverless service fashion, AppSync is inherently highly available and scales automatically according to demand. You can easily add geospatial search features to your application powered by Elasticsearch via the GraphQL API and make the data available in real time for users. AppSync supports all sorts of clients in all screen sizes, be it native mobile or web clients. It doesn't only work with PWAs, however, it's perfect for PWA use cases. Since it is a GraphQL managed service, fully compliant with the GraphQL spec, clients receive the data they ask for, nothing more, nothing less. You can retrieve data from multiple data sources in a single request. In our demo later on, we will use 4 DynamoDB tables. Another benefit from GraphQL, introspection and documentation out of the box, allowing clients to query the GraphQL schema, which also helps to document your data in the format it needs to be accessed on. We support React Native, Android, iOS, and JavaScript in general. Our SDK integrates with the widely used open-source Apollo GraphQL client. Since our SDK is also open source, it allows the Apollo team and our AppSync service team to contribute to each other's projects on GitHub. It's the beauty of open source. AppSync also allows write-through mutations with optimistic UI, providing a better user experience. What does that mean? Basically, it allows the front end to be updated optimistically first, assuming the server will be updated right after that. This is very useful in offline scenarios, as the user will see the interface updated regardless of the connection. In any situation or network state, real-time conflict resolution and offline capabilities take care of data consistency. Now let's talk about real-time. Before AppSync, in order to have a capable real-time application, you needed to have a fleet of web servers, a cluster of PubSub servers, maybe a Redis cluster, and a fleet of WebSocket servers. When you're talking about a fleet or cluster, we also have to take into consideration installing, configuring, patching, maintaining, automating, high availability, and auto-scaling all of them. That's lots of work in and on itself, just before you can get started with your app development. With AppSync, we remove all that undifferentiated heavy lifting, allowing you to have a fully managed and scalable GraphQL API endpoint in minutes, where you can start prototyping and developing your application very easily straight away. We do real-time in AppSync, taking advantage of GraphQL subscriptions using MQTT over WebSockets. For those who don't know MQTT, it is a very lightweight and fast PubSub protocol. Best of all, you don't need to manage those WebSocket connections. AppSync does all of that for you. Now let's talk about conflict resolution. Imagine we have a document sharing application. Our user Jane creates a document. However, Jane has to jump on a plane and goes offline. And Jane keeps working on the document in the plane while offline. John, who is back at the office, starts updating the document with some useful information, and does it one more time, creating a version 3 of the document. Jane then arrives at her destination and goes back online again. With AppSync, you can configure your application in such a way that a new version 4 of the document is created where all the updates are committed. This is done using request mapping templates, where you can configure different conflict resolution strategies: client wins, server wins, silent reject. But most importantly, you can create a Lambda function with your own conflict resolution logic for any custom requirements. It's awesome. Moving on to offline support. AppSync offline capabilities take advantage of different local storage mediums to store data while the client is disconnected, depending on the type of client you're using. Browser local storage for web, async storage for React Native, SQLite on native platforms. You can preload the database as well as configure the offline behavior to send data over Wi-Fi only or using Wi-Fi and cellular. Now let's address the elephant in the room, shall we? We talked about REST APIs and some limitations, and we talked about how GraphQL solves some of these problems. We have a fantastic REST API service called API Gateway, and now we have also a fantastic GraphQL API service called AppSync. Is it a matter of REST versus GraphQL? API Gateway versus AppSync? Well, it shouldn't be. It's a matter of best tool for the job. Why not use both of them? REST is not going anywhere, and it has been a truly tried and tested gold standard for many years with very good architectural patterns. If you have a simple API with few endpoints, REST is perfectly fine. Use API Gateway. However, if you have complex data requirements or you need real-time and offline capabilities, AppSync is here to help you. Both AppSync and API Gateway are fantastic and very powerful tools for your developer toolbox. But enough talking. Let's see it in action. I developed a chat application with a friend and fellow Amazonian in the United States, across time zones and continents, and it's now available on GitHub. We also wrote a companion blog post explaining the app, its components, and how it takes advantage of nifty AppSync features. Feel free to clone and try on your own AWS account. Thanks to CloudFormation and the mobile CLI, it takes only a couple of minutes to configure and deploy. It is a progressive web app, and it is called ChatQL. What's the best way to quickly demonstrate real-time capabilities? A chat application fits the bill perfectly. We have Cognito user pools onboarding and authenticating our users. A valid user receives a JWT token, which is sent to AppSync to identify and authorize the user. AppSync then uses resolvers to send and retrieve data to 4 different DynamoDB tables that store data about users, conversations, and messages. This is the high-level overview of the app's data model. A graph representation can help us understand how we need to store and relate data. The nodes represent the data we want to store. The edges represent connections, relations, or associations between the data. GraphQL allows to create relations between the data types, which means relations between NoSQL databases. This is incredibly powerful. Putting aside all the other great features, if anything else, AppSync becomes an amazing logic layer enhancing DynamoDB. So here we have our chat application I can access from my browser in my laptop, and I'm logging as Mate. Mate and Dude, they are best friends, and they are on this chat conversation. I'm going to open the chat application on my mobile device. As you can see, as it is a progressive web app, it just sits on my application drawer as any other mobile app. I'm going to log in with Dude. So, as I mentioned, Dude and Mate, they're best friends. And they have this chat application going forever. So I can send messages from my mobile device, and the message is received on my browser on the other device, and vice versa. So as you can see, the connections are done in real time. If I check the connection itself on my browser developer tools, this is basically just a GraphQL call. But this is a very long conversation. If I were to retrieve all the messages in this conversation at once, that would impact performance significantly. So if you notice the network calls at the bottom, as I scroll up, I start making more calls and retrieving more messages automatically. So basically providing that infinite scrolling user experience. This is done by the built-in pagination powers of GraphQL. It uses connections to do that. I am retrieving 10 messages at a time, and it uses basically cursor-based pagination. It has a token that let my application know when to retrieve the next 10 messages. But let's go offline now. So what if I go on a plane or I have no connection and I still want to send my message? So Mate's going to try to send a message to Dude. As you can see, I start getting errors because I'm not connected. I'm getting 504 errors. And my message doesn't get to my mobile device. I also have a green tick box that shows me my message was sent to the server, and a gray check mark that basically tells me that message is offline. It was not sent yet. As soon as I go back online, the app starts sending that message, and the message arrives on my mobile device on the other side. So that was all done automatically for me. And I can try again. I can send a message back just to confirm I'm back online. And I receive on my browser. But let's take a look at the backend. This is the AWS AppSync console. And you can basically create APIs there very easily. You can use a sample schema. It's going to create 2 DynamoDB tables for you, and it's an event-based app. It's an event app where you can basically start testing with your own backend straight away. But let's go back to our GraphQL application. So basically, I have a GraphQL endpoint, and I also can define my security settings there. So how I'm going to authorize users. I'm using a Cognito user pool in this application. I also have my data sources, so 4 DynamoDB tables, as I mentioned before. And I have my GraphQL schema. So this is where I define my data types and my data and relations between the data. And I have specific operations, the queries, mutations, and subscriptions. So if I go to a specific mutation, I can click on a resolver for that operation. So if the resolver, I define the data source, and I can configure also the mapping templates, which is use a VTL, velocity template, to modify the data before it reaches the data source. And also here I set up the conflict resolution strategies if I need to. But one of the favorite parts of the AppSync console for me is the built-in IDE. So here I can authenticate to my Cognito user pool and start testing and making API calls. So I'm going to log in as Dude, the same user that I'm logged in with on my mobile app. I also have a little UI component that has my username at the top there. And the great thing about having the app available on GitHub, so I can go to the AppSync resources page, click on the link, and I'm directed to GitHub. So in interest of time, I can actually access my GraphQL queries from GitHub. And copy them to the IDE itself. So let's just copy this query, paste on the IDE, and I can execute the query and get the data about my user. So as you can see, it's the user Dude. But what if I just want the IDs? So I just modify my query and execute it again. So I just get what I need when I need it. And because of the documentation introspection, I can, as you can see, it auto-completes for me, and I have all my data and my API defined as well, straight from the IDE. But let's actually run some mutations. Let's change the data about the user itself. So I'm going to copy this mutation. Paste to the IDE, and I'm just going to remove this part here and specify the username, a new username, maybe Ed. Oh, sorry, there was a typo there. Just need to remove the parentheses. And that's it. As you can see at the top of my mobile app, that a little UI component changed as well, from Dude to Add, because it has a subscription linked to that UI component. So it changes in real time. But let's change it back to Dude, because Mate will be really upset if it's renamed. As you can see, my mobile app changed in real time as well, due to subscriptions. If I if I refresh my DynamoDB data, the name was automatically changed. Now I'd like to share some takeaways from my experience using GraphQL and AppSync. Don't boil the ocean. Start small, test, try, and iterate so you can understand the concepts. Not every single UI component needs to be real-time from the get-go or need complex conflict resolution strategies. Use UI indicators to let your users know they are offline so they can relax and trust the application will manage the connection automatically and send the data when they're back online. Take advantage of the powerful built-in GraphQL capabilities such as pagination and relations in NoSQL. It's very important to provide a good user experience to your users so they keep engaged and coming back to your app. Progressive web apps and AppSync tick lots of the right boxes to make it easy and seamless. A good user experience will help create a loyal audience for your app. And if you're lucky enough, you can even make your users smile, similar to the first time I saw my nephew in that chat application. At the end of the day, it's all about the user experience. To gain more confidence and hands-on experience with AWS, access the digital training built by AWS experts. You can also attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. Validate your technical expertise with AWS and use practice exams to help you prepare for AWS certification. AWS has a wide partner ecosystem to help you focus on your success and take full advantage of all the business benefits that AWS has to offer. Learn more about how APN partners can help you and find the right APN partner for your needs. Visit the AWS APN booth at our showcase. Finally, I would like to thank you for attending today and sticking it out until the very end of the presentation.